So everyone can see the slide. So today we will cover the fifth lecture called Logistic Regression and Regression Trees. So last week we cover we have defined one binary and also multi-class. So today we will look into one of the methods used to perform classification, but this is more on binary classification. Okay. So when we talk about logistic regression, basically we are looking at developing algorithm to predict qualitative outcome. So normally we when we have our variable as label or ordinal nominal, for example, male versus female, purchase versus does not purchase, tumor is benign versus malignant. So we are looking into two variable only, two possibilities, yes or no. Okay. So this classification problem is best modeled with the probabilistic that are bound by 0 and 1. So if you look at here, the value of x here fall in between y0 and y1. So if you look at the graph here, so wherever you go, this part and this part. Okay, so basically, if we say linear regression, we cannot draw a line like this, straight line, because it goes to plus infinity and minus infinity. Okay? So the output that we get here, which is the y0 and y1. So whatever the value x is here or here, so the output is 0 when x is small value, and the output is y1 if the x is bigger. So how do we model this? We cannot use draw line because it goes to plus infinity, right? Okay, so we use this logistic regression in which the output is bound to 0 and 1 only. Okay, so this logistic regression is a special case of regression analysis and calculated when the dependent variable. See the dependent variable. So remember that you have independent variable that you use to model your dependent variable here. So whenever your dependent variable is nominal, so nominal means categorical value, male, female, or ordinal scale. Ordinal scales means you have order. Okay, so we can use this dichotomous variable, which involve two parts only, 0 or 1. That can be predicted by using a logistic regression. Okay, so basically we are trying to estimate the probability of occurrence of characteristic 1. So for example, we use age, gender, smoking status. We use this independent variable in order to model or find the probability whether the disease is 1 or 0. Okay. So like I mentioned just now, when we have all the x and y, no, x value here, all the x value here, but our y value is bound by 0 and 1. Okay, we cannot draw a straight line because it goes to plus infinity and also minus infinity. So the goal of logistic regression is to estimate the probability of occurrence not the value of the variable. So we are not trying to predict this one, but the probability of the value of the variable 0 or 1. Okay, so the range should be between 0 and 1. So in order to estimate this, we can use logistic regression, okay, logistic function. So when we talk about logistic function, basically they use the same formula here because we have this as your linear regression. Okay? But in order to bound the value of y between 0 to 1, we need to use the logistic function here, but we substitute the z here with the linear function that we have. So by having this formula, we will be bound to 0 and 1 only. Okay? So this is the formula that we have. Okay, so when we talk about logistic model in comparison to linear regression, you could have straight line, but when it comes to logistic model, the value for the y will be bound by 0 and 1 only, which is the probability of occurrence of certain value. So in this example, um, for example, male, female, or purchase, not purchase, and so on. Only two values, two different parts of the values. Okay, so how do we use logistic regression? Basically, we will perform the same process in which we perform data preparation, we perform data cleaning, handling missing values. So make sure you do not have any missing values. And then we split the data into training and testing. And then we test the model. So this is during the training. And then we use the same thing for testing. So let's see how we can use the logistic regression in order to perform some prediction. Okay. So in this example, we have Titanic data in which they have all the passenger ID and also the dependent variable here survive. So we have person who survived from the Titanic event. So over here we have all the data like the compartment class, the name, the gender, the age, number of sibling or spouse, number of parents or children, ticket, and so on, or which cabin and where they come from. Okay, so this is the um, definition of each of the variable. So basically, we are trying to model this dependent variable here. Okay, so the dependent variable has the value of 0 and 1. So we have dichotomous variable, which only has two parts, yes or no. Okay, so we have the gender, age, and so on and so on. Okay, so this is where they join the ship from which port. Okay, so if you look at these values, so we have numerical values, we have nominal values, and so on. So our output or dependent variable will be 0 and 1. So basically no and yes. Okay, so when we have this situation, then we can use the logistic regression. Okay. So once we read the data, okay, here we have this, we reading the data. So this is the data set. I will post the same data set here so that you can go through this step by step. And then over here, I say all the string will be maintained as vector. So all the string like name, sex, and ticket, they will maintain the label. Okay, so this is label. Okay, label. Label is different from character because character is just string of character. So we cannot assume them to be like nominal or ordinal values. Okay, so all the empty string will be replaced with the this is empty missing value, so will be replaced with empty string. Okay, so the header true means we also import the header of the file, which is the row name. Okay, so we have everything. So the first thing that we need to do is we need to check whether there is any missing value. So this is means not applicable, referring to missing value. So what we do is we will sum up the number of missing value that we have for all the column that we have in this Titanic dataset. So we can see that passenger ID, no missing value, survive, no missing value. So all this 0. But we have this age, we have this cabin, and we have this impact. So we need to handle this missing value before we can proceed. Okay. We also have this, we count the number of unique values that we have in each of the column that we have in our data set. So we will apply to all of the column. So basically this unique will give you the number, all the unique values, and the length will give you the number of unique value for each of the column that we have in your data set. Okay. So we can see that your survive here only 2, yes or no. Okay. We can also visualize the missing value here. So we can use this mismap. So mismap is used to plot or try to visualize which part or which column has the missing value. So if you look at here, this one cabin, we have a lot of missing value here, and also the age here, and also the inbound. Okay. So in order to handle missing value, we could ignore the whole features or attribute, or we could replace with the default value. Okay. So what we will do is we will remove this cabin from our analysis because we have too many missing values. And for the age, what happened is that we will replace the missing value with the average age for the whole rows that we have. So for the age, we will find the average, and then we will get that one as the default value. Okay. So for this one, we find the average to replace the missing value. For this one, we will remove. Okay, remove them. And then for this one, since there are only 2 records, so maybe we remove the record. Like this one, we remove the column. This one, we remove the row. Okay. So that's how we're going to handle this missing value. So how we're going to remove column and row, and also replace the missing value with the average age. So this is the command. Okay. So in this statement, we are basically not counting the cabin name, ticket, and also passenger ID because they are just name. So name does not have any influence in determining the survival of the passenger. So what happened? I will only select 2, 3, 5, 6, 7, 8, 10, and 12. So that means I will ignore the red features here. Okay, so this is we are getting the subset from this data set, and we focus on this column only. So column number 2, 3, 5, 6, 7, 8, 10, and 12. And then we store it in our new data here. So now we are focusing on this data, no longer Titanic. In the beginning of this step, we read the file into the Titanic. Now we are getting the subset of column from Titanic and store in the data here. Okay, so now we are using the data here. Okay, so by selecting only a subset of the column, we managed to remove this from our analysis. Okay, so the next thing is we need to handle the missing values for the age. Okay, so how do we do that? Basically, we are looking at, okay, we will find the average for the age, but in counting the average, we will not count the missing value. So that means if I have 440 rows and I have 40 missing value, so I will only take the average for the 400 rows only for the age. So I will not include the number of rows that has missing value. Okay. So once I get the mean here, so the mean average, so I will store in the data age where there is a missing value. So basically this one will give you all the column on all the rows that has missing value here. Okay. So this one is just updating the missing value with the average value of the age. Okay. So by having this statement, we already solved that one, the missing value for the age. Okay, so we can also look at the function is factor in order to determine whether the particular column is factor or character. So remember that factor is what? Factor is label. Okay, character is just a string of character. Okay, string of character. So this one we can check that, okay, our gender is factor, our inbox feature is also factor. Okay, so there are two missing value here. So what we can do is we can remove them. This one is just to show you what are the value for the female and male. Okay, so female is 0 and male is 1. Similar to this, C will be 0, 0, Q will be 1, 0, and S will be 0, 1. So basically this one simplify when we have something like this, we're supposed to have 0 here, 1, and then 0, 0. Okay, but we simplify them jadi 2 kolom pun boleh. Okay, okay, for the feature inbox, so how do we remove them? So we just say, okay, we will not include all the missing value when we have missing value for this particular column. Okay, so we will not include all the missing value that occur for this particular feature, and then I will update them to my data here. Okay, so by having this statement, we eliminate the rows that contain missing value for this column. Okay, and the last one is rows name data. When we first import the Excel file, we will have row name. So the row name is basically the numbering for each of the row that we have. Okay. So what we want to do is we want to remove them, and then we set to null. Okay. So that is the step on how do we handle missing value. So the first one is we remove the column. The second one is we find the average, and then we initialize that missing value with the age, the average of the age. And the last one is we remove the rows that containing missing values. Okay, so now you know how to handle column, rows, and then putting the average age to the missing value for the age. Okay. Okay, now we will split the data. So we have in the beginning we have 891, but we have removed 2 rows, so now we only have 889. Okay. So we will divide the data into training and testing data set. So this number could be ranging 1 to whatever number you want, but in this example, I'm taking the first column up to the 800. No, this is not column, this is row. Okay, so this is the first and one up to 800 rows. Okay, and over here, meaning that I will take all the column because I did not specify the number of column. So I just leave it empty, meaning that I will take all the column. Okay, for the testing, I will take starting from 801 up to 889, and I will include all the column as well. Okay. Okay, since we are using logistic regression, we will have to use the binomial. So in this function GLM, so GLM is stand for logistic linear regression. No, logistic regression. So we use this formula in order to model the data, and the data that we have is called trend, and this is the formula that we are using. So survive will be the dependent variable model using all the data that we have. So the dot here refer to all the column that we have in our data in the trend. Okay. So once we model them, so the output that we get will be stored in this model. So the output of the modeling is stored in here. Okay. So if we look at the summary of the model that we have, this is what we get, and the summary is like this. Basically, they tell you which features are very significant in influencing the value of the output. So over here, they say that the gender and also the age are very significant because, okay, normally we use this, right? The p-value is less than 0.05 in order to look at the the level of confidence. Okay, so but we see that we have 3-star here. That means almost 100%. Okay, so we can determine here that okay, this including this one again. So what is P class? P class refer to the ticket class. So whether you are in the first, second, and third class. Okay? So based on the output here, the compartment class also determine the survival rate of the individual person. Okay, how do we use this model? Because this is just the training part. And how do we use this model? We have this model already. So what we can do is we can do some prediction. So the prediction here will use the model that we have trained. And now we are using the test dataset, but in using the test dataset, we will not include the dependent variable. So we are not including that one, because if you look at our data here in first place, okay, here. So we have this 12, right? So the 12 here referring to this column. Okay, so for the testing one, what we want to do is we only pass the data for here, and then we try to predict this one. Okay, so that's why in the prediction here we only have 2, 3, 4, 5, 6, 7, 8. Okay, so meaning that we will not include the dependent variable. Okay, so when we perform prediction, all the output will be stored in here. Okay, so the output for each of the row could be just the value that indicate the probability of having survive or not survive. Okay, so we take the result here, and then we need to convert them into 1 or 0. So over here we are saying that if the value of the fitted result is greater than 0.5, so I will put 1. So otherwise I will put 0. So this is just to convert to 0 and 1, because this result just showing you the probability of surviving and not surviving the Titanic event. Okay, so we have all this updated result. Okay, so what happened is that we will compare the result with the actual. No, this is the predicted result. We will compare with the actual result that we get. Okay, so over here we will check the number of results does not match with the actual one. This is the predicted survive value. This is the actual one. Actual one. This is the predicted. So we want to know how many of them. Okay. So once we get the misclassification error, then we can get the accuracy here by subtracting the misclassification error from 1. Then we get this 0.84. Okay. So this is the accuracy of the model. So next time when you have new data, so basically you are using the same command here. Okay, so basically we are using the same command here. We use the model, but this data will be a new data set for you. So the type response means they are fall between 0 and 1. So whatever data you have here will be the prediction. Okay, so you don't have to compare again this, because this is only for testing. But if you have new data coming in, then how do you do the prediction? You just call this function, and it will give you 0 or 1. So corresponding to the data that you include in this prediction. Okay. Any questions? If you're still with me, can you type number 1? Okay. Okay. So that is all about the logistic regression. Okay, so we will take a break 5 minutes before we proceed. Let me stop this.